Hello and welcome back to Unit 5, Lesson 2. Here we're going to be talking about solving multi-step equations. Hopefully, I saw some of you did view the Lesson 1 video that I posted. Again, please, I know it was probably like I spent way too long in that video, some of you thought, but for some of you, or maybe some of you, it might have been like slightly, I don't know, confusing the way I explained it. But I really explained it in a way so that it carries through the entire unit. But if you did have any questions, again, feel free. Please feel comfortable in leaving a comment below that video or this video, or feel free to send me a message and we can work through them. Again, the idea basically there was, when solving equations, we either, the idea, there's a couple of things to remember. First thing is the inverse operation. So the inverse operation, we talked about addition, subtraction is the inverse, multiplication, division is the inverse, that kind of thing. And the shortcut for doing it, so the basic idea here is we do the inverse operation to both sides to kind of isolate for the variable. So in a simple case like this, x plus 5 equals 13. The variable is already on the left side, which is nice, so I want to get rid of the 5. Actually, that might be too easy an example. I'll do this example. The idea here is I want to collect all my variable terms together, so I'm going to move this 4x over to the left-hand side because I want my variable on the left-hand side. Now, the way we do that is, again, when you're thinking about inverse operations, you have to be careful. So if I'm moving if your object is to move the entire term from one side to another, you're doing like an add subtract kind of operation. So you would add 4x to both sides, or you can think of it as moving this over to the other side and where this negative 4x becomes a positive 4x, because again, that's the inverse operation, negative to positive, right? So you move the 4x and you get x equals whatever's left on this side, which happens to be a negative 5. For some questions where, again, we saw like this, again, this 1 is what I had to move first. And the idea is, okay, like how do I know to move the 1 first and not the 3? The second important thing that we talked about, I think I had it somewhere, was the reverse BEDMAS. So normally we talk about BEDMAS where if we're trying to solve for something, if we're trying to calculate or simplify a big bracket, you go brackets first, then you do exponents, then you do division, multiplication, then you do addition, subtraction. In this case, we're going to go backwards. So first we get rid of any addition, subtraction. So here is the plus 1. I'm going to get rid of that first before I start doing the multiplication bit. So, which is the 3x. So I'm going to move this minus 1 over to the other side. It's going to become plus 1. Or you can think about adding 1 to both sides. That's the inverse operation. And then once you combine 14 plus 1 to 15. Now here, you can think about it in two ways. Like, okay, 3x is a single term, and I'm kind of splitting that term up. I'm trying to divide the 3 out, right? So I'm splitting that one term. And so therefore I have to do a multiplication division kind of switch. So when this 3 moves over, I'm going to divide it by 3. Because another way you can kind of think of it is, okay, how is the 3 affecting the x? Or how is it disturbing? It's like, I don't want the 3 with the x. How is it interfering with the x? It's multiplied into the x, so when I move it to the other side, it's going to become division. That's another way you can think about it. And again, whichever way you think about it, it's very crucial that you understand the patterns here, because once we get to lessons 5 and 6, there's going to be like all kinds of weird fractions and exponents and all that stuff. So you don't want to really you don't want to go wrong you don't want to make silly mistakes, is what I'm saying. So we're going to continue with lesson 2. And before we officially start, happy Easter. If you are indeed watching this on Monday, well, if you're watching it on Tuesday, or later than that, belated happy Easter. Hope you had fun in a safe and, socially distanced manner. And we're going to, and hopefully we're back into the studying mode after, I know it's kind of hard. Some people are finding it difficult to get into that mode when you're like sitting at home and you can't, like Netflix isn't blocked by like the internet kind of thing, because it is at school and it's not at home. But the idea is hopefully we are focusing in on our work, because regardless of what happens now, you will be expected to know most of this when you get to grade 10. And I guess it's useful that you do have these videos now, because you can always look back on them and refresh on some of this material later on. Hopefully, I think I will keep them on my channel for a bit. But okay, we're going to start with the lesson now. Okay, so we want to transpose terms so that variable terms are on one side. So we look at this equation here. I have 5x minus 6 equals to 2x plus 8. Again, I want my variables to be on one side of the equation, usually the left side. So what am I going to do here? First, I'm going to move this 2x over to this side, where it's going to be a minus 2x. Again, it's technically a plus 2x here, right? And when I move it, I'm moving the entire term. So I'm doing a kind of addition subtraction flip. So positive becomes the negative there, equal to, again, this minus 6. I'm moving that entire term over to this side. So again, the addition subtraction flip is going to give me a plus 6. You can also think of it as, subtracting 2x from both sides and then adding 6 to both sides. Okay, whichever way you want to think of it, that is fine. And I'm sorry if I'm skipping a step here. Hopefully we're okay with that. And I'm going to get to here 3x equals 14, I believe, which, again, that's just what it is. Whenever I get some things like this, I always double check to see if my work is right, because I'm expecting whole number answers, but yeah, you can't change math. And here again, if we take a look at this again, I want to isolate for x. So how is the 3 bothering the x? It's multiplying into it. So either I divide by 3 on both sides, or I move this 3 over to here. And because I'm splitting up, 3x is one term, right? We talked about monomials. 3x is a monomial term, and I'm kind of breaking that in half. I'm splitting it into the number part and the variable part. So I kind of do a multiplication division switch. So it was multiplied here, now it becomes divide, and I'm just going to leave it as 14 over 3. That's my answer. So now let's check. How do I check? If we remember our check, we have to start with an LS and RS. Put a line there. Our LS was 5x minus 6, correct? And what is x now? We think x is 14 over 3. So what is 5 times 14 over 3? This is 70 divided by 3 minus 6. Take a common denominator, which is 3. So this is 70 minus 18 divided by 3, which is in fact 52 divided by 3. So that was our left-hand side simplified. Now our right-hand side is 2x plus 8, which again we will sub in whatever x was. In this case, we found x to be 14 over 3. We're going to check if our left-hand side and right-hand side of the original question is now the same, if x does indeed equal 14 over 3. So I'm going to do 2 times 14 over 3. Again, hopefully I don't have to remind you how to multiply, 2 times 14. Don't go and do, 2 times 14, 2 times 3. Remember, this is just 2 over 1, right? Just multiplication of fractions. You multiply the tops and you multiply the denominator, and 2 is just 2 over 1. So the denominator stays 3. And again, I take a common denominator here, so times 3 times 3. So I get 28 plus 24 divided by 3, which is actually 52 divided by 3. So you'll see here that I got the same answer. So I just say LS equals RS, x equals 14 over 3 is checked. I mean, you don't really have to write that. You can stop here. LS equals RS. That's my check. And now I've shown that my answer was in fact correct. Hopefully we are also not confused by the fact that to take a common denominator, I've made visible this invisible 1 for any whole number that's the denominator, right? So I want to be careful there. Okay, we're sorry. Question or example 2. Okay, first we're going to read what it says. It's a nice hint that we're given there, make sure brackets are expanded and each side is simplified before transposing terms. So what does that mean? It doesn't really apply to the first two questions, so we're gonna talk about that a bit later once we get to part C. But here, okay, we're doing the same thing. Usually we want variables to the left side, numbers to the right side. You can do it either way. Like, I'm going to do it another way just to show you. So here, what I'm going to do is I'm going to take this negative 2x. I'm going to move it over to this side. I'm moving an entire term, so I'm doing a negative positive flip. So when I move it to this side, it's going to become 3x plus 2x. I'm keeping the 3x there because I'm collecting all my x terms to the right-hand side, which is, again, not proper form, but I'm just going to show you that it's the same thing. And so my constants go on the left side, so this negative 17 has to move over here. I'm moving the entire term negative 17, so it's a minus plus flip. There's already an 8, a positive 8 that's chilling over here. Once I move the 17, it becomes positive 17. So what I get here is, in fact, 25 equals to 5x. If you had done it the other way, what would you have got? If you had moved the 3x over to this side, you would have got negative 5x equals negative 25. And that's the same idea because, again, here, once you do this, you can, hopefully you're okay with, I'm just flipping the equal to sign, right? If, like, you know, if something on this side equals the same thing on this side, then if I flip them, they're the same. They're still equal to each other. So hopefully that's not confusing anybody. And again, once you can collect them to either side and turn them around, this now is in proper form. And now again, so I have to get rid of the 5, and when I have to move the 5 to the other side. So you got to think about it. Okay, am I splitting a term? Yes, I am. 5x was a term, and I'm breaking that term up. So, or you can think of it as, how is the 5 interfering with the x? It's being multiplied into the x. So I have to, when I move it, it becomes division. So any kind of thinking that you're doing, but hopefully we see that we have to divide both sides by 5 or move the 5 to make it a division, whatever you want to, whichever way you want to think about it, you get x equals 5. And of course, if it says check, you have to do 8 minus 2 times 5. That's the left-hand side, and the right-hand side is 3 times 5 minus 17, and you would make sure that those are the same things. In this case, that's weird. They don't look to be the same. Why are they not the same? Did I do something wrong? 8 minus 10 is negative 2. Oh, yeah, they are the same. Whoops. Okay, so now let's take a look at this. Okay, now I have a lot of terms here, and I can start moving things around. But before that, I'm just going to look at my left-hand side. I have a 2x and a minus 3x. Right away, I'm going to combine those two terms, and I'm just going to, I'm just going to say negative x. Because if you simplify things before you start moving them around, there's less stuff to move around, which makes it easier. Negative 5 plus 1 is negative 4. And let's take a look at the other one. I have 7x minus 8 minus 2x. Again, I have a 7x minus 2x, which is a 5x. And a negative 8 just goes as negative 8. There's nothing to combine really on that side. But now if you look, I have much less stuff to move around. And again, I'm going to do the regular way. I'm going to bring all my variable terms to the left. This was a positive 5x. I'm moving the entire term. So this becomes a negative 5x. Equal to negative 4 here. I'm moving the entire term. So this negative 8 was already there, but now it becomes positive 4. So minus x minus 5x is negative 6x. This is negative 4. And now, again, I'm moving, here's where you have to be careful. I'm moving this negative 6 over to this side. And again, some people here is where they might tend to, mess things up and say plus 6 on the other side, but you have to be careful. I am splitting a term here. Negative 6x is one monomial, and I'm cutting it in half. And so I have to do a multiplication division kind of change. And so if I move this to this side, it becomes divided by negative 6 because it was multiplying over here. So negative 4 divided by negative 6 is in fact 2 over 3. So that is my final answer, x equals 2 over 3. Again, you could have moved the x over here, and you could have made everything positive and nicer. But again, it's up to you, whichever way you want to do it. Hopefully we'll see that we get the same answer. Okay, let's take a look at this. Now, when I said do brackets last, I meant, so when I talk about reverse bedmass, that means you have to kind of open up the bracket at the end of your moving things. But in this case, if we take a look at this, we can actually expand some stuff inside the bracket first. So again, we're not transposing yet. So we're not doing the reverse bedmass. We're just trying to simplify the left side and simplify the right side individually before we start to kind of move things around. So we're not at reverse bedmass, we're not moving things around yet. Here we can just say 14 minus, again, distributive property, open up the bracket, negative 3 times 5t is negative 15t, negative 3 times negative 12 is positive 48, equals to 1. Again, remember here that this negative means both of these terms change their sign. I'm doing negative 1 times this and negative 1 times that. So 1 minus 20t minus 1 is what my right side is going to simplify to. So I'm going to 14 plus 48 is 62 minus 15t equals 1 minus 20t minus 1. 1 minus 1 are the like terms. That just becomes 0. So here I have a negative 20t. It occurs to me I've done something wrong because 3 times 12 is not 48. 3 times 12 is in fact 36. So this actually becomes 50. Yeah, whenever you don't get whole number answers, you always got to check your work. You might find that you've made some, silly multiplication mistakes like I just did. Don't do that on a test, please. Okay, now we'll take a look at this. Again, you kind of have to, as you become, okay, like I know I said, like move all the variable terms to the left, move all the number terms to the right, and then simplify. But as you get bigger, as you get, better at doing these things, hopefully you'll realize that it doesn't matter which side I move things to. And I'm going to choose the side that involves the least amount of work. So here I already have the only number term on the left-hand side. And if I just move this over to here, that's going to give me the variables on one side and the numbers on the other side, or the constant terms on the other side, which is what I'm going to do here. So again, I'm moving the entire term. So I do a addition subtraction flip. So what I'm going to get is 50 equals 20t plus negative 20t plus 15t, which becomes negative 5t. Divide both sides by negative 5, and I have t equal, or negative 10 equals t, which I can also write as t equals negative 10. Your final answer is usually good to write in a form where you write t equals something instead of something equals t. But whatever, it's not really a huge thing. Use an equation to determine the value of x and state any angle properties used in your solution. This is an interesting one. Use an equation to determine the value of x. Now this is hard, simply because it's kind of difficult to do this unless you know. Again, here we know that this x plus phi is referring to the angle because of the units of degrees that are on both of these things. So they're not side lengths or anything like that. This is the angle which has a measure of x plus 5. This is the angle that has a measure of 3x plus 10. This angle it's not given to us, but we actually know it to be the angle x plus 5 degrees. And how do we know that? We know that angles corresponding to equal sides are equal. Not exactly sure if that's exactly how the rule is stated, but the idea is if these two sides are equal in a triangle, these two angles will also be equal in a triangle. So I think that's what you have to say. Like this angles corresponding to equal sides are equal. It's a bit of basic geometry there. I don't know. I'm not looking at the answer key. I don't actually know if that's what's actually stated, but hopefully something of that sort is stated on the answer key. and even if it's not, this is the idea that you're using. You kind of have to know that this is equal to x plus 5. And now, hopefully now we're okay with how we find x, the main property, Lagrange theorem, or the, as it's commonly known, angle sum property of a triangle. And we know that the sum of all angles in a triangle add up to 180 degrees. So if I do, x plus 5 plus degrees plus another x plus 5 degrees plus 3x plus 10 degrees, this is all going to give me 180 degrees, because I know in a triangle all the angles add up to 180. So that's the angle sum property of a triangle. You put that in brackets, just because it states any angle properties. I guess that's a triangle property. So I'm gonna, of course, simplify this. I see a plus outside the bracket, so I'm not really changing the bracket. So this is just x plus 5 plus x plus 5 plus 3x plus 10. I'm just gonna get rid of all the brackets without doing anything, because I just pause adding the brackets. X plus 3x is 5x. 5 plus 5 plus 10 is 20. Again, now here's where like my reverse BEDMAS. So first I'm going to move the 20. I'm going to move it over to that side and subtract it from that side. So I get 5x equals to, in fact, 160. And then I'm going to break up this 5x term by dividing both sides by 5. And so I get x equals to 32 degrees, I think. There. Yeah, okay. 3 plus, 10, 2. Yeah, that I think it's 32 degrees. So that's my value of x, and, well, that's my answer. So, ta-da. Okay, let's take a close look at this. 5 more than double the number is the same as 10 less than triple the number. Determine the number by first writing an equation and then solving. Okay, first step, whenever you have a word problem, what are we going to do? Write a let statement. Never forget that. Even if it's like just like a number, you have to say let n represent the number, or x represent the number, whatever variable you want to put there. I'm going to use n for variety's sake. So let n represent the number. And okay, okay, the easiest way to read word problems like this, it looks like a bunch of like word, like Scrabble, like stuff, and like 5 more than double the number, like, but and realistically, like, like you're not gonna get. It's just good to. The reason we're giving you questions like this is to build kind of critical reading skills. It's actually like ties into a lot of English, where you have to like read each. So as you get like as you do like future English lessons, you'll kind of get the hang of what we call critical reading, which is looking at a sentence and understanding the meaning of each word and interpreting that in terms of the sentence, the paragraph, the entire story, etc., etc. It's very complicated. I'm not very good at it, but I can do the math version. So let's read this word by word. 5 more than, so that's 5 plus, so 5 more than, so something plus 5, double the number. So n was the number, so I'm going to do 2n. You can write 5 plus 2n is the same thing. This is 5 more than, double the number. Is the same as, so wherever you say is or equal to or is the same as, that is just, in math terms, that means an equal to. 10 less than, so something minus 10 is 10 less than, triple the number. So triple the number being here 3n. And this is, again, this is 10 less than, that's minus 10, triple the number is 3n. So again, read it word by word and kind of put the mathematical expressions to form your equation in the end. And now it's just, moving things around. I'm going to move this 3n over here, make it minus 3n, and move this 5 over there, make it minus 5. So here I get negative n equals negative 15. And so whenever I have this, I'm going to, you kind of have to envision that -1 over there, that invisible 1, which I'm going to move over to this side. And since I'm splitting up a term, I'm doing, it was -1 times n. And so I'm splitting that negative n up. And so I'm going to do multiplication division switch. So my n equals positive 15. And then you can just check this. Okay, double a number is 30. 5 more than that is 35. Triple the number is 45. 10 less than that is also 35. And you don't even have to do a formal check. It's just, you just read it and see if it makes sense. So yeah, it does make sense. So that was this. Again, it's not, I don't think it was too much more complicated than what we did in the last lesson. I'm gonna, I think, go over some of the homework to see if there's any complicated ones. 221, let's give that a look. 221, where am I? 218, 219, 220, okay, 221. Okay, it says 5, 6, 8, 16, 21b. So let's take a look at 5. Again, make sure for like questions like these, you are in fact, or like even this, you are simplifying the sides before transposing, but after that it's fairly easy. You should be able to do this. In fact, I'd like you to think of actually what word problem would be used to represent this this equation. So I can actually give you a word problem which says the sum of 3 consecutive numbers is 54. Find the smallest number, for example. So you say let the smallest number be n. So the consecutive numbers means a number that comes like right after it. So in this case, it would be n, and then the next number would be n plus 1. The next number would be n plus 2. And the sum of them, if I add them all up, gives me 54. So this is actually the word problem which represents that equation. But again, this is just 3n plus 3 equals 54. You just move stuff around, and that doesn't seem too difficult either. Make sure, okay, in these cases, always you're going to expand the brackets before, on this side, before you do anything. There are ways in which you don't have to do that, but it's easiest to expand the brackets first. We'll get to complicated ones later. What else are we talking about? 8, 16, 21. Okay. A number n decreased by 5. So again, number n decreased by 5. Number n decreased by 5 is equal to 3 times the number plus 1. You just read it word by word and put in the expressions. And you can solve that, of course. Again, these are not part of the homework, but very important to take a look at them because these are, very good application questions that might show up on an assignment. Word problems, the perimeter of a rectangle is 36 centimeters. The width is 5 centimeters less than the length. So again, let a W be, let L be the length. So the width is therefore 5 centimeters less than the length. So L minus 5 would be the width. And then dimensions of so the perimeter is given to be 36. So we know the perimeter is 2 times the length plus 2 times the width, which is 2 times the length plus 2 times the width we said was L minus 5. Very important to put that in brackets. But then here we know how to solve this from now. 2L plus 2L minus 10, I'm using distributive property here, equals 36, and then, etc. You just add 4L equals 46 and move it, blah, blah, blah. You know how to do that. George is 3 times as old as Sam. 5 years from now, the sum of their ages will be 46. So again, let X be Sam's age. It's always useful to pick S as the lower number, I find, because you're doing multiplication addition to find the other ones instead of subtraction or division. So let X be Sam's age. So George's age is 3x right now. That's today. right? So 5 years from now, the sum of their ages will be 46. So 5 years from now, how old is Sam? X plus 5. 5 years later. So it's straightforward, right? If Sam is like 12 today, like 5 years later, he's 12 plus 5, 17. So this is Sam's age. And what is George's age? George's age is 3x plus 5. Because today, George was 3x years old. So he was 36 years old. 5 years later, he's 36 plus 5. Right? So you're just adding 5. So this is George's age. And now, okay, so now the sum of their ages will be 46. So 5 years later, x plus 5 plus 3x plus 5 equals 46. And then you just solve this for x, and that's Sam's age today. And you just multiply that by 3, that's George's age. So there you go. Should we do this? This looks like fun. I would actually I don't know if this is a part of a later homework. I hope it is, because it's a very good practice. I'm going to hopefully remember to come back to this question when we later do fractions, but we'll skip it for now and we'll move on to I think what else was said, 16 and 21b. Let's look at some other questions. Okay, all this looks like a part where the fractions come in. So okay, show that the equation 2x minus 3 equals 4 plus 2x has no solution. Why do you think that happens? So again, we're going to try and solve for x here. And what we actually get is if we move this 2x over to this side, we're going to make this 2x was over here. If I moved it over to this side, I get a minus 2x because I'm moving the entire term, equals 4. I'm moving the minus 3 over here to make it plus 3. And what I get is actually 0 equals 7, which is not possible. And so therefore there is no value of x for which 0 equals 7, right? This just doesn't exist. So why do you think that happens? Because let's take a look at this. This is what this equation is: 2x minus 3 equals 2x plus 4. So if I take some number and I subtract 3, it will never be equal to that number plus 4. That's like, that doesn't happen. It's not possible for that to happen, and therefore that's why it's not possible. So it's an interesting thinking question. 21b. Oh, okay, you know how to do this. This is, again, just angle sum property of a triangle. And actually, you can try and take a look at C as well. This is an interesting question because we know that this entire angle here is 180 degrees, right? So this part of the angle is actually 180 minus 3x, right? Because this was 3x. There are, of course, other ways to do this. If you remember the exterior angle property, you know that 3x was actually equal to this angle plus this angle. And so you can kind of say that this angle was actually 3x minus 2x plus 10, which is actually x plus 10, so that would be x plus 10. But it doesn't matter. Whichever way you're solving this, this is 180 minus 3x, the same rule we used before. This is also 180 minus 3x. So 2x minus 10 plus 180 minus 3x plus 180 minus 3x equals 180, right? Angle sum property. You can try that. And if you remember something from parallel lines, you should be able to try this. We know that this is a Z. Have you done Z pattern? Okay. Some of you in grade 8 might have learned about Z pattern. If not, never. Don't worry. We'll be learning about Z pattern in our geometry unit later this year. But the Z pattern says that these two angles are equal. So you can just say 2x plus 15 equals 3x minus 10 and solve this equation. If you don't know what the Z pattern is or what I'm talking about, don't worry about it. We'll learn about it later. So this is not part of the assigned homework. So I believe that was most of the questions here. We can take a look at some of these questions actually. These are all very good questions to ask, and I think this. I'm just going to try A and B here to illustrate what I mean exactly by reverse BEDMAS and why that becomes important. So if we take part A here, if we're taking a look at part A, we'll see here that, again, first thing is I do addition, subtraction. So I'm going to remove this 2, move it to the other side. I have 3x squared equals 25 plus 2, which is 27. The next thing I do is multiplication, division. Here that means the 3, right? So I'm going to divide both sides by 3. And so I get x squared equals 27 divided by 3 is 9. And then I deal with the exponent, which is, you know, if I have to get rid of a square, I'm going to take the square root of both sides. So that cancels out the square, and so I get x equals 3. Or technically negative 3, but we'll, you know, just say 3. I think that's enough for a grade 9 level. And part B especially, because this is very important. Because we haven't learned how to expand brackets where we have a variable inside the bracket. We haven't learned how to expand brackets with exponents attached to them, I should say. And so therefore here again, reverse BEDMAS. First we get rid of addition, subtraction. So we're going to move this -1 here to make it +1. Then we're going to divide both sides by 2 because it's the division multiplication. So divide both sides by 2, I get x plus 1 squared equals 36. And then now I take the square root because next comes the exponent, right, in reverse BEDMAS. So first I did addition, subtraction, then I did multiplication, division, then I did exponents. I'm doing exponents right now. So the square and the square root get canceled. I have x plus 1. And square root of 36, we'll just say 6, even though it's technically also -6. But we'll just say 6 for now. And then I deal with the bracket. So now this, whatever's inside the bracket is the last step. So I move this +1 over to here, and I get x equals 6 minus 1 is 5. And this is what I mean by doing brackets last. If you have a bracket with an exponent attached to it, you don't open the bracket before you kind of move things around. The bracket stays till the end. At the last step, you open the bracket and finally isolate for x. So this is where reverse BEDMAS comes in handy. So yeah, that was that. I don't know if we should try 23. It's getting to be a long video. 102, the ratio of a price. Okay, so so we can say the price of a small candy is X. So the ratio of a price of a large candy to the price of a small candy is 7:4. So like large candy divided by small candy is like 7/4, which is actually like our large candy divided by 7:4, and therefore this might be okay. I'm just going to show you how I would do it. The large candy let's take as y for the time being, or we don't know what that large candy price is. We know the small candy price is x. I'm going to do cross multiplication here, which actually gives me 7x equals 4y, and in fact y equals 7x divided by 4. So the price of my large candy here is 7x/4. And then therefore you have to do 500 times 7x/4 plus 400 times x equals 102, and then solve that for x. That is quite complicated, and it does involve fractions. I don't know if we'll do that later, but for those of you who are looking for a challenge, I'd recommend thinking about this. And how I got this. If you can understand that, that's good. So, yeah, take a look at that. Until then, I will see you with the next lesson. Of course, you do have this worksheet, which is very nice for homework. So, do the worksheet. Is my pen not working? Looks like oh, there it works again. Do the worksheet, practice. If you have any questions, of course, you can feel free to post a comment below this video, and we can talk about them. And then I will talk to you next time for some more exciting work. which is actually the lesson 3. So talk to you soon. Until then, peace out.